the thing I tried and that worked very well was to use Fable. I don't know if you know.
I heard about Fable, yeah.
So Fable is a.
But maybe explain it to everyone.
Yeah. So Fable is a template and some tools in F# so that you can write F# both server side and client side, and do all the rendering using Elmish. So I will explain. So I have a server that is in F#. I will go back to that after. But I also have a client which is in F#, and it will actually be transpiled to JavaScript and run in the browser in JavaScript. So this is my client. I can show you. This is just a demo application of Fable. So I will show you. It's very simple. How do I hide the small thing here? No, I don't see it. So here it is. So this is, there is someone who wants to enter the room. I admit him.
Oh.
Yeah, sorry. So this is the save template, and it's very simple. So I can just, there is a counter, and I can press plus minus, okay? But the very cool thing is that it's written in a Elmish way. So the Elmish way is this. You have a model, which is a counter, which has a value or no value. And then you have messages, which are increment, decrement, and remit of a client message. It's cool. And when you initialize the page, the counter has no value. And then there is an update function that says, when I receive this message and my current model is this, my new model is this, and I also send this message. I think it will ring some bells to you.
Yeah.
This is actually just an immutable update function. So here I take the counter on my message, and if I have a value and I increment it, my next counter is counter with a new value +1. And I can also send to the server the fact that I just incremented it. Okay.
Okay.
This is here. I send it over WebSocket to tell the server, okay, I did it. For the decrement, it's the same thing, and I send it. And when I receive a value from the server, I just update the value in my counter with the value from the server. Okay. And for whatever other value, I just do nothing and return the same model on the same command. So everything is immutable here. So I just get a state and a message, and I return a new state. And I can also say, run also this command that can either go back in the same loop or trigger something that will trigger something else asynchronously or something like that. Okay. But this model is very simple. And then the cool thing is that you have a view, and the view is using the model to create some HTML. So I get a model, and I will just render the actual HTML as F#. So I say, okay, I have a div with a nav bar, which is with a string, which is heading H2, and a container that is, this is all wrappers around HTML, okay?
Yeah.
So for instance, I can show you that you see that my counter is at 39.
Yeah.
Okay. And now I will change the text of my button by saying minus and plus. And when I press it, I think it's here. It should be, yeah, it has been changed, and my counter, it was reset. It should not have been reset, but I don't know what I did. Normally it should just, but maybe I did not. Yeah, I did not implement enable the hot reload. But You can also enable auto reload so that it will change the page, but just without
Right. So that's like
losing time.
for
This is
hot
just,
like WYSIWYG type of editing. So you can
exactly.
work on
So,
your HTML or you actually work on your HTML through F#
yeah.
and see the changes immediately.
Yeah, and this is totally some F#, and actually it's running in JavaScript in the browser, and all the semantics is here, and you can do all the types you want and whatever the complexity you want in F#, and you get the JavaScript that just behave exactly like that. The very interesting things also in the fact that you can have auto reload even if it's not enabled here is the reason why you have auto reload is that since all the state of your page is in the model structure, when you change the code, you will have Webpack, which will send a message, and Fable will just serialize the model structure, reload the code, deserialize the model structure, and call the view to render a new virtual DOM, and just change the old DOM with the new one. And you can continue with the same state. If you have an error when you try to reload the state, just rain it and you start from fresh. Right. But if the state is still compatible, you can just continue to run. But the only reason you can do that is that you have a very clear model of where the state is and what action you can do. Okay.
Yeah.
There are only three things: your model, the update, and the view.
Yeah.
And there is no other way. There is some state in your application. Okay. So this is why it works, okay? And this is something that goes very, very, very well with event sourcing, because the first thing I did for gaming, because the first thing I did is to start to write this code I showed you in F#, but I put it in the shared section of the code, because here I have shared code that is included both in the server code and in the client code. So this is F# code, and I can write function here, okay? So if I write some code here, it will be executed in F# on the server, and it will be executed in JavaScript in the client.
Nice.
This is the same code, okay, written once. So all my code that I showed you about hexagon and all that, I put it here. And I just created a few functions that convert my hexagon's coordinate to screen coordinates. And actually, it's even producing some person coordinate, so that when you resize the board like that, everything resizes correctly. Okay, so everything is in % of the actual size of the board. And this is just some, a bit advanced CSS, but there is nothing very tricky. This is just % and all that. And once you get it right, you can just start to write very basic code like what I will show you.
Well, CSS is making its inroads into everything. There's even operating systems that do their windowing decorations with CSS.
Yeah.
So
drawing a player. It's just like that. So draw a player at the XY position. I create a div with a player class. And if it's selected, I add the selected class. And the styles are left and top with the value.
Nice.
In %, okay?
So how, just out of curiosity, how advanced is the CSS? Is this pretty much it in terms of like...
you mostly for all the board, it's mostly % like that. So I compute % to be able to place things on the board. So I have just a small function that can convert my X coordinates to %. I have to find it. I think it's just a bit before. Yeah, this is here. So I just found some right values for it given the design of the board. And of point, so I take pure on R, and then I just compute, and you can find this computation on the website I showed you
right,
before.
yes, of course.
And so
but I was just wondering if there's any CSS specific things like the variables and all this other stuff that CSS
no, nothing fancy like that.
Okay.
And after that, so there is also a slight rotation because actually the board is not straight. So I had to apply a small rotation to the actual value displayed before.
Oh, I didn't notice that. There's a slight rotation to the board.
But as you can see, it's not straight. So I had to apply a slight rotation.
Oh, yeah, it is slightly rotated.
Yeah. So I had to find a nice touch because that fits well.
This is because the art came back this way?
Yeah.
So you wanted to make it exactly the same. That's cool.
Yeah. And after that, globally, color names here. And to draw a parcel, I just take the position of the parcel in pixel, and then I rotate it. I get X and Y, and then I just create a div, which is a tile, which given values. So this is a small computation to be able to actually change the design of the tiles over the board, but they are always the same at the same place. Okay.
Right.
So it's slightly offsetted in direction, so you don't have two tiles which have the same design at the same place. And after that, just left and top in %. Okay. So this is really simple.
Very cool.
The hard point is to get the CSS to get squares that can change size, and that is always a square is totally not obvious.
Okay.
Because actually you have to make a background and make a 0 size div, which has 100% top padding.
Yeah.
Why, I don't understand, but this is how you can do it.
Okay. And this does what? This makes sure that everything's displayed all the time, or? Yeah,
no. With that, you will the 8 will be always the same as the width.
Oh, I see.
So then you have to take care that the width is appropriate based on the rest of the size, but you know that it will be always a square.
Okay.
And then for all the rest, like cards and all that, I use a mix of these techniques and the Flexbox.
Okay.
Yep. So
it flows nicely with the different sizes of the browser window.
Yeah, and so you can play on mobile, you can play horizontal, vertical, and all that, and it works. But there is no complex computation in the code, just a few transformation I showed, and the rest is % and CSS, and it works. So quite easy. So I started to quickly iterate using safe and F# in my creating the CSS to have things at the right place. I just had to create a model with a few tiles, a few fences, and the player's token, and I could start to get a visual quickly. Okay, because I had the right model to actually display it, and after that I had to make actual actions. Okay.
Yeah.
And at this point I decided to go functional event sourcing. For several reasons, and I will not say all the reasons now, but one of the one of the reasons is that of course I wanted the game to be distributed, because here you've seen me playing on a single computer, but of course the goal was to play with remote people. So I wanted to have synchronization between players.